Alright, let's see what we can do with this old code here. Alright, let's see if my YouTube shows up. It does. It already is there. Hello, YouTube. Let's pop out our chat. Close that down. Okay. Gain the focus again. Move it over there. Doesn't move. Move it over there. Now it moves. How do I, what do I, what? Computer? How do we do this? We just want to put it right, whoops, right, computer. Let me just, there, there we go. Okay, we got the tubes, alright. So what do we want to do with this? Let's see if we can do, oh, that went over there, okay. Let's see if we can do a clash. Bright lights, bright lights. Bright lights. Let's do a clash. Come on over to clash, bright light. Okay. Where did my tubes go? YouTube's is there? Okay. Alrighty. 2 seconds. No! Clash now. Oh no, a repeating message is interfering with the message your friend is trying to send you. Given the jumbled message jumbled, and the repeating message interference, you need to recover the original message. In order to recover the original message, you must remove the interference from the jumbled message by exploring the jumbled message and removing character by character in the interference from the jumbled message in order until there is no more characters to read. Okay. Until there are no more characters. For example, say your jumbled message is that and your interference is that. In this case, we try to find A. It exists, so we take the message up to there and discard the A. We try to find B, and okay, I get it. Abadabadoo. Okay, and the original message is that. Note that out of order characters must be kept. Out of order characters must be kept. For example, if your jumbled message is BAC and your interference is ABC, the B and C are not in sequence from the interference and are thus part of the original message. So the program should give an original message of BC. Okay. So, alrighty then. We're obviously going to be doing some work on this. So let's just print out the jumbled message there. Alright. And for giggles... Oh, wait. So the jumbled... Okay. So then what we want to do with each one of these, we just go like this. We want to keep track of an index. We'll call it the int I index, the interference index. So if jumbled sub I equals interference sub II, and then we're gonna, where did that go? Okay, string original. Okay. So if jumbled equals that, we don't want to copy the thing. Otherwise we do. Otherwise we want to go original plus equals jumbled sub I. Right? Alright. So if they're equal, we don't copy. Otherwise we do. And then if they are equal, then we found one to skip. So we go II plus plus. That will take to the next interference. Yeah. if II is greater than interference.length, then II, we'll just do that. And then original jumbled, cout jumbled. Okay, so let's not cout jumbled. So at the end of that loop, we want to cout original. See what we get there. Hello world, and the answer. Oh, answer? So what? Oh wait, what? It exists and is at the start. We only discard E. We try to find A. And so we keep cycling through. Oh, if it's greater than length, then we want to set this back equal to 0. That's crazy. But it did not work. What are we doing? 0. Jumbled equals interference I plus plus. I is greater. So what is the first one here? Interference is 1 character long. So jumbled I equals interference I plus plus, right? And then we'll just say, we'll check that, and then we skip this so we don't add anything to original. So let's see out original here. Let's just see how my original, because what am I getting? Whoops, and that's not, okay. So HE and then I shouldn't do it. Boom, 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 boom. I should stay constantly at 0. Oh, greater than or equal to. Whoops. Whoops. Now I bet we're getting it. We don't want to print it out there. Print it at the end. Okay. All right. And then we got it. I think we got it. Boom, 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 boom. Okay, we got it. I was only off by one thing. By a little equals. Yeah. And we're getting it. Nice. Bam! We got another C++ contender finished in Pi time 3.4. 3.14. Let's look at this beautiful code. Look at this. Int j, string current. Int j, is that a interesting. I don't recognize that. Is that an array that he's making, or I think that's an array. Int I is less than jumbled size plus plus I. If jumbled I equals inter I, cout to current. Current equals nothing plus plus j. J mod equals inter dot size. Oh, okay, that's cool. J mod equals, interesting. Oh, so it, okay, so what? J plus equals 1, j equals j plus 1, j equals j mod inter size. Oh, that's cool. I never thought to do that. That's cool too. And I like how he's doing the pre plus plus. It's prepended. Alright. Else current plus jumbled out current. Okay. And what else? JavaScript. Jumbled index, jumbled interference, error. Console log jumbled split filter. Oh, there's a lambda. V interference, V equals X, index plus interference length false. Oh, kind of the same thing. Okay, joins. Alright. Are you going to finish Lannert TV Severe? Alright, 7 minutes, we'll wait. I think we'll wait. Okay, so where is the shader for this? We need to open this as well? Okay. Oh, the shader's inline. Oh, Jeff. Past Jeff. So much to do here now. Oh my goodness. Alright. So, let's just use it the way it is. I know it's clunky. Ba, 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 ba. Alright, so what we want to do is copy this to something else. And then we have the other. Okay, so go like this. Main first point equalizer 2. Cleanup. Do we have main equalizer 3? Let's just go copy it right to main equalizer, because we're going to make this a little equalizer thingy. EQUALIZER. Okay, 0. Let's go 0, 4. Whoop, whoop, whoop. Okay. So main equalizer 4. Basic classes maze sphere 4. We need to put that into here. And then let's just go actually, hold on. I want to look at cleanup and see. Basic classes maze. So 1 through 4. Okay, cool. 1, 2, 3, theme 3. Okay, 4. So let's just, sorry, what was I doing? File save as. Not in there. So we have 4 already. Let's go with 5. Go like that and save that. Okay. So that's cool. Let's make sure we can get it to run here. Main maze sphere 3. Remove. Add existing main equalizer 4. Okay. There we go. Now let's load the last equalizer as well. Main equalizer 3. And everything is contained in this one. So SFML audio, IO stream. Okay. This is not a class. It's just this right here. This is it. So we're going to integrate this with the maze, and we're going to get a nice little display. It's going to be cool. Did he finish F#? Interesting. Okay, open system, let jumbled equal console in readline, console in readline, let swirl s string equals string dot concat seek dot tail s plus string sequence dot head s. I think that means sequence, I don't know. Let result equal jumble, interesting, something greater than, sequence dot fold, fun s comma r, that looks like a lambda. If sequence dot head s equals x, then swirl s comma r else s comma r plus string x. Interference comma string empty. Print fn percent s snd result. Wow. It doesn't look like he's I don't know. Definitely not talking me into F# anytime soon. One more time. Oh, I'm in charge of this one. 2 minutes. I'll be right back. Sorry, I'm catching my breath from doing exercise here. Whew. Whew. Oh, do we get it? We get it? We get it? I even forego the first minute. I don't care. Shortest code. Bah. Gah. Is that gah? No. Okay, 11 minutes. All right, that gives me time to work on this here. So really, what do we want to do to make this thing look... Computer, come here. What do we want to do if I talk, right? Well, first of all, let's see if we can shrink this down and make it expand out, because that's a good size. That's a good size for the maximum. Maybe stretch it all the way to the whole screen. And then what the person can do is just capture just the window and then shrink it into the corner, do whatever they want, right? Okay. I like the dots and stuff. Those are really cool, but I don't think we should keep them. But it would be kind of cool to see the effect just reveal the dots. Maybe we can just keep the dots as a background, I guess. I don't care. I really like them. I used to be about... Yeah, I had a really cool... I should probably make it again. I have not done that in OpenGL yet. I should. Huh. Anyways, I had random boxes all over the screen, random dots flying around, and just bouncing off the boxes, going inside, you know, some... spawning inside the boxes, bouncing inside the boxes like that, you know. This looks really cool for like a language, too. Just like an alien language. So many things to do with this particular demo, I think. So, alright, so main equalizer 4. Let's go to all projects. Vtuber. Okay, so we're going to update this one. Main equalizer 4. We're also using basic classes maze sphere 5. Okay, and then the other one was main equalizer 3 is where, because the equalizer itself is really, really small. Somebody else got it in Python in 58. Congratulations. 0, O equals X, oh, for I and X, if O negative 1, oh, the previous one is not equal to I, then O plus equals I. Nice. I actually understand that. Cool. Coo-coo-ca-choo. Alright. So how much time do we have on that one? I have bread coming out of the oven in less time than this, so my bread will come out, then I'll check the time on there. Oh, this class has the system. This class has the system and... Okay. Sorry, I'm eating a grapefruit. Peace. Oh, computer. Very funny. Very funny. Alright, generate random boxes. Select top left. Organize boxes on screen. Add point. Change sign. Initialize angle offset for each row. Actual offset temp. Okay. Draw sphere maze 0. Print so far UD. So far 2. Alrighty. Circumference and max radius divided by max points. Circumference of max radius divided by max points. 6.28 times 0.75471 divided by 90. Oh, my bread's done. I'll be right back. I'm sorry, that's my brain. My brain. Don't mind my brain. Alright, so let's see here. So how do we... I remember being able to do that. Ba-ba-ba-bum. See, add point. Draw sphere maze. Okay, so it's all in here. Seal... D radius, radius points, circle points. Oh, and then I do all the math right here. D angle, circle points, circle points. Okay, so we could just apply a simple scale factor. Mode 0, mode 1. What's 0 and 1? Is 0 the initialization, and then, okay, and it's random. And then 1 is the update. Oh, I gotcha. Okay. So draw maze sphere, is that sphere maze, is that, where's the update points? Points move. Our list, determine index for particles, rotate maze sphere, draw sphere maze 1. So it updates this angle offset for each of the things, and then it draws this. Okay, I gotcha. I gotcha. So we're not going to worry about that. We're going to let it do its thing because it works just fine. And then what we're going to do is just add in so we'll add in a scale factor, and then we'll have to add that to all these calculations, which is not a big deal. Add point, let's look at that real quick. It's just XY, RGBA size, type X, type Y. Okay. So index XY, RGBA size, type X, type Y. Okay, so XY. So add point is where we do the scaling. Actually, it has X ratio, and then it's got the Y. Okay, so we just need a scale factor. And we already have the X ratio on there, so I tell you what, let's try to put in a scale factor, and we'll just set it equal to 1. And then I think it's not too important that we do it in the initialization, but it's very important that we do it in mode 1. But we'll do it in both. Do it in both. Oh, sorry for snorting. So let's go draw sphere maze. So the scale is going to be a factor that changes throughout. It's going to be a factor that changes with time. Scale factor changes with time. Actually changes with volume of mic audio. Okay. So let's go scale factor, GL float. Actually, we need a vector 2, sorry. GLM vec2. And we're going to call it scale audio. Let's call it scale volume. Okay. I'm going to forget that, so let's just take it down here, copy it in. And for now, what we're going to do is set the scale factor equal to, we're not going to mess with the volume quite yet. That will be next. That will be next. So we're set the scale volume to 1. Uh-oh, what happened? What happened to the music? Then comes light. Okay. Light is on the way. Everybody relax. What's it called? Didn't I just copy it so I can put it in here? Yeah. Okay, so here we're going to want scale volume.x times all that. Okay, and we can just put that in here. All right, let me use the mouse. So this is really handy to use. Don't just multiply it by this x ratio. So scale factor dot x. Okay, 9, 10. So each one of them is, yeah, and so it's going to be 18, 27. All right. And then the next one is going to be the y, which is over slightly. It's right here. So we're going to go scale underscore volume dot y and times. Just right there. Boop. 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 Computer? What are you doing? But they're both going to scale the same, so I'm not sure why I'm using x and y, but maybe eventually later I'll want to do some funky things with ovals, I guess. I don't know. Okay, so let's save that. The scale is 1, and so let's make sure we didn't break anything. Of course, multiplying by 1, oh, we did break it. How did we break it? What? What? So how did that break it? Seriously? Scale volume, what did I set it equal to? I set it equal to 1. Oh. So if I multiply these by 1, I don't get it. How does that, what? We're going to have to think on that one, folks. That one's bizarre. Read line, sprint, reduce, PC, slice. Okay. Whatever, bruh. Your cryptic JavaScript. Not readable by moi. Jumbo888 is following you. Hey, Jumbo. What's happening? Alright. So why does multiplying this by 1 change everything? Why does it change? Why does it change everything? I have no idea. You can't. How does multiplying by 1? It literally never changes. And this is draw sphere, right? Draw sphere. I am confused. X, Y. Oh, you know, we can do that there too. We can just do it at add point, because add point is called at every, so I don't need to add it to all these places. Let's do this. I am confused at the moment, so let's go edit, find and replace, quick replace. That with nothing, all of them. And then go find this. Quick replace. All of them. Okay. So it does call add point every time. This one does not call add point every time. So add point. Let's run it again now that I've taken those out. Okay, so it's normal. So let's just do this here. 1.0 times. Just in one spot, I'm going to multiply by 1, whatever that is. I don't know why that would change anything. Nothing changes. Did I make a mistake on some of that other stuff? I might have, did I have a typo? I don't understand. Okay. So this is what's modified here. Let's go, and for now I am just not going to worry about ovals. I'm just going to use one scale factor. We're going to use a float. Scale volume equals 1. Okay. So we're not going to worry about the initialization. We're going to put it in here on all of them. Is that what it was, or is it underscore? I forget. What did I just call it? And I've still got this up here. Alright. Scale vol. No underscore. And again, it's only 1, so I don't understand why 1 changes anything. Let's just run just this. Oh, it why? Why is it doing that? Multiplying by 1 is significantly reducing the size. I don't get it. I do not understand. Wow. So what about X ratio? I'm multiplying by 1. I don't get this. It's got to be some kind of... Oh, weird. That's beautiful, though. Okay, it's got to be some kind of data thing. This is not multiplying by 1 and having an issue. This is an issue with data manipulation, storage, whatever. Visual Studio is totally messing with me right now. Let's put the actual number 1 in there. Okay, see? So it's the retrieval of that data. So if the retrieval of that data is going to be a problem, then how could I even do this? Doesn't make sense. Doesn't make sense. This is so bizarre right now. Could it be the name of this or something? Let's just say, like, what all variables are we using? Let's use QQ. Is that a good safe variable name? I have no idea if it's... Okay, we're setting QQ equal to 1. Yeah, okay. I am not going to be doing this because I can't. Unless, what happens if we set QQ equal to 2 or something? I mean, like, is this... Oh, it goes smaller. See, now that's just, there's something weird going on. So what if we go 0.1? Okay, you got me, folks. Anybody out there sees any kind of something about this that makes sense, let me know, because this doesn't make sense to me. I really don't get it. Let's see what's going on step by step here. So QQ is just, let's take this one step at a time. Okay. Let's go down to the first one. And let's multiply by QQ on the first one and see if that changes anything. Yes. What is going on? So I can't have a variable. Okay, so let's not have a variable in that class. There is a lot, to be fair, there's a lot of data here. Not that that's quote unquote being fair to me, but, and it's at the end, so, D Heaven 125, thanks for the follow. Let's move this out of the class and put it into the main here. We'll make it a global right here. We'll just go GL float. We'll call it scale volume equals 1. And then when we multiply in here, let's just do it right down here. So when we call draw sphere maze with mode, and then we will also send in a float, and we'll just call it multiplier. So we'll go to draw sphere maze. So we'll send in that float. Computer, are you alright? It's alright now. Okay. So then when we call, it's not called in here, draw stuff. Nope, it's called from, right, it's already pointing it out to me. Draw sphere maze 0. And when we call it here, oh, but it's okay. It's okay, points in it, and then we'll send in, we're gonna, okay, let's go back up here. So we're also gonna receive the float here. And there, this is a huge workaround. This is like going way above and beyond what we should be doing here. So points in it, we're gonna receive a float. Call it multiply right there. Draw sphere maze already receives that. Points move down here. We're also going to receive. Okay, and then when we call draw sphere maze here, we will just send that variable through. Because we're going to receive it from the main, then we're going to. I don't like doing this. I really don't. I don't like doing it. So scale volume, and it's at 1. So points in it. Does the other one update stuff is fine? Is everything fine? What's this? Points move. Okay. Oh, we call, okay, so update stuff has to receive it. Okay. See, this is why it should just be a, maybe I should declare it as a variable. I don't know. Let's try that second. We'll modify everything here. We're just going to make everything crazy. Okay, so we're going to send a float to update stuff. And then down here, what's this error? Update stuff, we'll receive a float, GL float, MUL. Points move, we will send MUL through. Okay, so that one, mul is the thing. Okay, we're calling it mul in so many places, it makes me uncomfortable, but whatever. And then here, are we good? No, update stuff, we need to send, I forgot that scale vol right there. Okay, so we're just sending the number 1, multiplying the number 1. Okay, we're good. So did we multiply? Did we multiply? Hold on. But we didn't multiply down here. So now let's put mul here. Okay. See if this works. Ah, see? So there's no problem. Alright, so now, actually, that's convenient that it's in main because we're going to put the equalizer from getting the mic volume in main. So that's fine, actually. It's crazy, but fine. So let's go into here. Let's look at our includes and see what we need to include. So we need SFML audio, IOStream, CMath, vector, cone IO we don't need, vector we probably have. We probably have IOStream and CMath. IOStream, we need CMath. Okay, we also need SFML audio. We don't need IOStream, already have it. Okay. There we go. Okay, that part is done. Then we need this class in main. Private, okay, so let's go like this. Main equalizer. Okay. So in main we want to instantiate the audio processor. We don't care about that really. This is really simple actually. Audio processor. We're just going to go into main. Init there, let it do its thing. Then we will instantiate the audio processor here. Then we're going to check if it doesn't have a microphone, whatever, start processing. And then we already have a loop going, so this is going to be before the loop. We'll just go there. Then we just get the volume here, pass it through to the functions. This processor.getVolume, that will be a multiplier on the, and then at the end we stop processing. So that's going to be down here with cleanup right there. So in here, yeah, we want to send it through here. So it's going to be 1, but let's go look at what this is. Okay, so processor get volume, and what is this? Get volume returns a double. So this is all we want, really, right here. And then we don't need it anywhere else but right here, scale volume. I don't remember what the maximum and minimum is, but let's cast it to a float. Does that work? That works, okay. Let's see what that does, because that should be already quite interesting to see. Okay, so that works. It's just that it's, yeah, so let's multiply it by like, it looks like we could multiply it by 0.25. This is crazy. So 1/4. And we also need to add the lerp. Okay, so hold on, let me go get that lerp stuff. Because we had the lerp. Where is the lerp? So when we send it through here, hold on, what was the other one? Main equalizer 2? Did I not have a lerp in there? What happened to the lerp? Oh, is this not the latest one? That's okay, let's go look at the latest one. I'm just looking for my lerp code in here. Oh, here we go. Okay. Okay, let's go like this. Hold on. So the first thing we do is calculate the current time and last time of the interval. Oh yeah, we had an interval. So where was that? Interval. Anybody seen my interval? Oh yeah, sorry. So time variables, alert variables. Oh, we need those. Okay, let's take those. Let's steal those for just the remainder of this. Bum, 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 bum. So, yeah, let's put them up here. Doesn't interfere with anything else, I don't think. Okay, last time, do we actually use the... Okay, so this might be changing. Okay, let's go back down here. This is nothing, 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 nothing. Okay, current time equals get time. Points. Okay, if current time... So do we do the time in here? If get time minus timer is greater than... timer equals get time. What are we doing there? We're locking the frames per second. Okay. So let's just go... What this one does is last time equals current time and interval. Okay. So we have those variables now, so we can actually use this. C volume equals get volume normalized to a maximum of 8. C volume times equals 75. I don't think we're going to do that. Set the target size. Then adjust the size of the points and update OpenGL different target current size. Okay. So we want all that code. Minus all those comments which are now in the way, but let's just put it right in there. Take out all these crazy comments and stuff. Shrink it down. Or wait, let's leave that. Those are good comments. Set the target size. Okay, we also need a variable called current time. Like that. Okay. So current time minus last time greater than interval. Okay. Is that okay? And then we want to cast that to a float because that's a double. It's not a big deal. It's just going to give a warning. All right. Reset timer. Last time equals current time. Cvol equals processor get volume. Okay, this currently we're multiplying by 0.25. Let's just leave it in its raw. So cvol is going to be the temporary. Retrieve and print the volume samples. Okay, whatever. Normalized to a maximum of 8. I think I figured that out. Cvol times 0.75. Set the target size equals cvol. Target size? We want to normalize it to a maximum of 1. So if let's go cvol equals get processor divided by 8.0. That should normalize it to a maximum volume of 1. And then we can just check to make sure if it goes a little over 1 or whatever. Okay. Then we just get rid of this, set the target size, calculate the difference. That's going to work now because we stole everything. Okay, current size plus equals current size. That's going to be this number. So difference equals target size minus current size, adjusted lerp difference. Okay, let's try that. So now we can just put current size in there. Maybe. See if that does. See if this'll does it. And what do we got? Oh, it is lerping. It looks nice. It's just, you can't really see the maze because it's never big enough to see it. So let's do this. So right here, cvol equals get process. Let's divide by, so we're dividing by 8, and it goes from 0 to 8 probably, is what I remember. So let's add 4, and then we'll go cvol divide equals 4. Oh, divided equals by, so we're going to add 4, it'll go up to, actually let's just do that. We're just adding 4 to it. There you go. It's bigger. It's bigger. It moves quite quick. I remember adjusting the... okay, so we can adjust the way that it goes down. So adjust lerp speed, difference lerp speed times 1.5 or lerp speed. Where's lerp speed? Okay, speed of the lerp. Let's just slow it way down. Let's go down to that. 0.2. Okay. Current size, target size? Oh. There we go. So that's not much of a slower lerp. And when it's at 0, I still don't like... Let's see what we got here. So the initial size, okay, let's start at 8. So we'll do twice the size. Because it looks like it's at 0.5 when it starts. And then, yeah, and then let's slow down the lerp speed even more. Like way down. Like, so instead of 2, let's go 0.5. So that's just 4 times less, I think. There, so that's full size. Oh, it's not lerping out. It's because the maximum is 1. Okay, so now let's go back to here. It's greater than 1.5. We'll set it equal to 1.5. Now we'll let it go up to 1.5. So it's going to go between 1 and 1.5. Now I've got my voice on there. And you can see the maze, and it's cool. Okay, the only other thing to do... Actually, I like the background too, because it doesn't ever interfere. Huh. Well, what do we think? And now, how did we get the click to change the theme? Hold on. There was a way. Let's add a button click, button toggle, button count. But I don't know that we're ever using that. But let's see. So inside here, when we're doing our points in it, boxes, our color, random, organize boxes on screen. Okay, so the color TC, oh yeah, TC. So where is that initialized? TC equals T colors. Yeah, okay. Oh, right here. Right here. So they're set right here. So, and that's inside the class. Okay, cool. So all I have to do is call a function, change those colors. Oh, but it's not done here. Ah, well that's okay. So we can just do an update function when we click. So we'll update the colors, we'll update the data and call the update, and then we'll just do that when we click. Alright, so first of all, let's go down here. Actually, we'll go back to the top, right up here. Let's go like this. We're going to call this void update colors. I don't think we need any input. Void basic update colors. Okay, so computer, all right, okay, it's fine with that. Good. Now, so the way we're going to do this is in here we're going to trigger on a left click. We're going to call basic dot update colors. Does that have access to basic? Or wait, let's just, since I don't think it has access to basic, let's go down here. So process input, swap now, update stuff. Let's put it right here. If button, no, what was I just looking at? OpenGL.button count. It's greater than 0. Then we want to go update, or wait, no, basic update colors. Wait, why is it? Oh, is it? Oh, I got you. Hold on. I'm not doing that right. So this is all OpenGL. Is that what I called it? Hold on. There it is. Basic OpenGL. Okay, so never mind. So button count, button toggle. How come button count goes up? Button equals. We'll just try it and see if that works. And actually, we do have access to OpenGL here. So OpenGL.update colors. We're just going to call the function. We're not going to worry about button counts and all that. So update colors here. Okay, so what we want to do is cycle through the TC. There's 40 of them. Oh, but we only use 2, right? Draw maze sphere. How does it do it here? TCJJJ. Num rows. Oh. Alright, hold on. So we're just going to have to take this code. I haven't worked with this code in a while, but we're just going to have to take that code. Hold on, where is it? J num rows. That's all we need. We need this loop, and then we're going to just shrink it way down. There. For our update colors here. J equals 1 to num rows. Okay. And then all we need out of here is none of this. I circle points. If mode equals 1, is that inside this loop? It's inside the I loop. Let's take out mode 0. Each I equals 36 floats v index plus 0, 1, 9, 1, 2. Well, okay, so it just uses I for the position. Okay, so we don't need the I. And the v index plus 36. Oh, we do need the I loop for the v index counter. Okay. Whew. Boy, it's been a while since I've worked with this stuff, but that's okay. V index. Yeah, it's just a glue int. Okay. So let's do that here too. Okay, j equals 1 to number of rows. Circle points? Oh, are we not? Circle points equals 120. It's a float. Oh. Actually, let's just put 120 in here. Even though it's a float, we're not going to use a float. Okay. So multiply ratio. Okay. I guess no, we're not going to need that because we're just going to do the colors. So instead of using 0 and 1, which is the x and y, let's look at the data real quick. Our list kinds, points, so far kinds. Okay, it's not there. Okay. It's the add point function I want to look at briefly. Here it is. XY RGB. Okay, that's it. Size? XY RGB, so 2, 3, 4. Hold on. Like this, 2, 3, 4. Okay, so we need those 3, and we need those 3, and we need those 3, and we need those 3. Okay. But we don't need these 2. And then this, got to be 2, 3, 4. And then we're going to set the new, what we're going to do is we're going to set the new, set new palette colors here, and then populate colors in maze here. All right, 2, 3, 4. So we're just going to put colors in here, and then 9, 10. Whoops, where are we at? V index, so this is going to be 11, 12, and 13. Okay. Okay, this one's going to be 20, 21, 22. Whoops. Oh, nice. 29, 30, 31. There we go. So those are all the colors. And so first we'll set the new palette colors here. So when we do the initialization and we set the colors initially, where is points in it? Da 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 da. TC, where's that? Right here. TC colors, it only does 4. T colors, I2 equals that, and it just does 4 random colors. It only does 2? It only does 2? Interesting. Actual offset temp C, IJ. Num rows, temp C, TC, I plus J equals T colors, temp C. 0 or 1 times quick. Oh. Quick 25. Oh, and then it does a thing right there to kind of. Okay. I gotcha. So whatever color is chosen in the palette, it also does a variation of that color, darker, lighter, which gives a huge variation in the colors, which is nice. So let's just choose 2 random colors. Randomly choose between the 2 colors. Randomly choose a variation of one of those colors. Angle offset TC I plus J T colors. Draw sphere maze. Okay, and then draw sphere maze 0 and 1. 0 is the only one that sets the color, so TCJ. Oh, TCJ. So where does TC? Oh, I plus J. Next. Oh, num rows and then next. Oh, wild. I'm not sure that I can do this. Alright, let's take these out. It's going to look random, though, if I do it wrong, which is not bad. Okay, so set new palette colors here. So theoretically what we did, let's go again, let's look again at init. Where is it? Points in it. Okay, you know what I want to do? I want to take this. Well, let's just do it one step at a time, I guess. Okay, so generate random boxes. These are all the boxes. Okay, that doesn't matter. So change sign next round. T colors 4. Glue into I2 equals 0 to 2. So T colors, just two random colors. Even though we set up for enough room for 4. Next is random 3 plus 1. So 0, 1, 2 plus 1. So 1, 2, or 3. Okay. Number of rows I plus next minus 1. So that's just kind of random. Actual offset equals that plus that. Temp C equals that. J equals 0 less than or equal to next. J plus plus. Angle offset I plus J equals actual offset. Oh, because as you're going around. Okay. If change sign angle offset times equals minus 1. Quick equals that. Change sign next. Let's see. We got to go to Bing. Oh, sorry, I forgot the Clash. Busy, been busy, been busy. Okay, Let's see if just that will get me what I'm looking for. I kinda doubt it. Sure. Here's a simplified version of your code. Only focuses on the color initialization. Oh. That's what I was hoping. Okay, so we can actually do this. So T colors. And T colors is only used inside of that particular function, right? It's not used outside. Okay. So T colors, temp C, quick equals that, TC sub I equals temp C. But what about that inner J loop? Hold on. In this version, a group of next consecutive rows will have the same color. The next value is randomly oh, that's what I did. Okay, that makes sense now. It's randomly chosen between 1 and 3. Check the IJ. Okay, so I actually just want to change the colors, not the... okay, hold on. Oh, I remember this now. Okay, so TC I plus J equals color. So why don't we... Oh, because it's also randomized, so yeah, okay. So let's just change the palette altogether. Let's go with this version. Yeah, here we go. So up here, set new palette colors. We use the T colors. Next equals that's fine. T colors, I, rows, next, temp, C, quick, J, TC, color. Alright, so I think that'll work. And then as long as next doesn't go beyond 40, do we check for that? Oh, we still need a mul, so when we call that, we send in the float. Or no, we don't need that. No, we don't need that. Sorry, take that out. I was like, we don't need that, because this is going to be colors. This is going to be TC, and then this is going to be from mode 1, or up here, it's going to be TC in the inner loop J. Oh. And then what's that, 0? Oh, that's redoing the, oh, okay. So if it's 0, we don't change the color. Oh, otherwise we won't have a maze anymore. All right, I forgot about that. That's good. So what we need to do is check, do, okay. Hold on. We could also change the maze each time and just redo the maze when you click. Just get a different maze and different color, everything. That would be kind of cool. Do you want to do that? Do we want to do that? I think we do. So let's go if rand 2, 1 equals that. Otherwise it equals that. Oh, that's right. So if, hold on, let's just. So for each one. Oh, let's see. So C, okay, hold on. TC, so number of rows here is 60. And next, I plus J, so TC, I plus J since TC is a maximum of 40, and I think that's the number of rows, let's just go like this and make sure it doesn't go over 40. And then right here, we could just make it, we can just do the maze here again. Do we want to do that? Do we want to do that? Or do we want to check and see if it's already... Let's just gamble on this. If our list to the index plus 2 equals 0, and and this one equals 0, and that one equals 0. Okay, then if they're all black, then we don't do that. Actually, let's just go if it's greater than 0. And that one's greater than 0. And that one's greater than 0. Alright, then we'll go here. And then we're going to go TC. So here is TC I plus J dot R. Oh, computer fine, computer fine. Okay, but we're also going to go I plus J mod 40. No, are we just going to let that go up? I think, I don't know. Or is this I plus J? Yeah, mod 40, I think. We're screwed. We're screwed. This is going to look wonky. It's going to look so wonky. I'm not doing as right as why. Now I'm not motivated to do the rest of it like this. Alright, let's just copy this. 1, 2, 3. A 1, a 2, a 3. Okay, so now we're going to go here and change this one to 11, this one to 12, this one to 13. Then we're going to go 1, 3, 2, 1. Okay, and then here we're going to go down here and delete that. Alright, 20. The index 21. Oh. Okay, now we're going to go here and we're going to go 20, 21, 22. The index plus 20, 21, 22. And then here we're going to go 29. Here we'll go 30, 31, 29, 30, 31. If this doesn't work, I have another way that I'm thinking of. I could do it. So this will do, and then we need to call the update. So, but that should update, right? Update colors, and then after update colors, what happens? Update stuff. But I don't think we want to, or yeah, the colors will be changed. So as soon as it does the next update. All right, let's just see. We might be screwed. And it's only left click, right? Okay, so left click. Oh, it changed it. And it did work. So left click. Oh, it doesn't do all of them. But it's still cool. It does change the colors. Alright, that's cool. That's a lot better than I was thinking. Honestly, to be honest with you. And yeah, that's really cool. Okay, I would like to start it a little bit smaller and have it go to that same height. So let's go back to, where are we at? lerp speed. We could still slow down the lerp speed a little bit more, so 2.5 there. Okay, and back to here. Up to here. Where was it? Points move. Oh, it's the mole. It's up in here. Sorry. Down here. So add 8, divide by 8. Okay, so let me think about this. So if we're adding 8 and then we divide by 8, we just want to add, keep that, I think. Let's add 6 and divide by 12. Or 10, divide by 10. So that starts smaller and lets it go to, oh wait, let's keep it divide by 8. Or let's go even smaller, 6. Add 6, divide by 6. That makes it bigger, right? I think it'll go bigger, but it doesn't go back to smaller. Plus 6, let's go, let's not add to it. I'm not sure what's happening right now. I'm not sure, whoa, did you see that? Okay, that's too big. So we definitely want to add something here. Let's add 4 and divide by 7. I'm just playing around with numbers, really. Ooh, that looks good. Oh, that looks good too. Okay, maybe we're dividing by too much. So divide by a smaller number. Let's go back to 6. Let's just, or go to 5, go to 5. Make it bigger, make it bigger. Okay, so it starts bigger. Oh, interesting. Oh, ba 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 bum. Oh, that's the maximum. All right. Cool. All right. Okay. Now I wanted to start smaller. How come it keeps starting bigger? I want. Get processor volume plus 4. And then divide by 5. Maybe we should add afterwards. Let's get the volume and divide by 5. And then we'll add C volume plus equals 4. Wait, that'll be too big, won't it? It'll go to 1.5. It'll just go to maximum. Alright. Hold on. Well, let's see what just that does. Just 0 and then divide by 5. There is it. So that just goes way too small. So 1.5 maximum? Okay, hold on. I know that this goes from 0 to 8. And what I really wanted to do is vary from like 0.5 to 1.5. So from 0 to 8. And then from so we wanted to vary by 1. So divide by 8. Okay. Now take CV. And that's going to go from 0 to 1. We just want to take CV and add 0.5. There, now you're doing it. Now I think you got it. Yep, I think that's it. And then when we go up to maximum, okay, cool. So now that's too small. But that's okay. So this is the minimum right here. Let's go 7.5. Let's let the maximum go to 1.75. So now it starts bigger, and then it'll grow to a maximum. Okay, cool. I think that's cool. And then the other thing is the shader, which I haven't really looked at. But the shader does in type distance equals that. If dim section equals 100 and distance is less than 420, discard. Distance is less than 420. So that we can send in a multiplier to vary that too, depending upon. See, like, what if I just take that out? Distance equals distance, dim section equals that. Okay, let's comment those two lines out. I don't think we use distance any other time, do we? There, now you can see the dots all throughout. There's no filter effect. All right, cool. So, and now I can take this. Let me look at my stream for a second. So that's my stream right there. So what if I go to OBS? And what if I want to... Let's take out the display capture. And let's add a window capture. Add existing. Create new. Window capture, okay. Make source visible, yes. Properties for window capture 2. Learn OpenGL, perfect. So then, let's just match title, otherwise capture cursor, okay, whatever. And now let's shrink it down. And I can move it to the corner. And then let's put the display capture back. And now I've got that operating in the corner of my screen. Is that right? Oh, cool. Then if I go here, so now if I go there, it doesn't show up on my screen as I'm working, but the viewing audience at home can see that. Oh, so what does that look like full screen? Oh, it's not clear that it's a maze. But if I go maximum, what does it do? Oh, okay. Well, interesting. It looks really cool, though. So that's very cool. Maybe we could make it bigger or whatever. We could make it a good portion of the screen. And then nobody will be able to see what I'm working on. But actually doesn't cover as long as I work in this upper portion of the screen most of the time. So I just gotta remember to like here. My cursor's over here. Yeah, so it's right about here. And then I'll have this. Does it show that it's a maze there? Do you see the max with maximum? Maximum. Okay, yeah, it does. Okay. Alright, that's enough clowning around. I've done enough clowning around. I'm going to eat bread and get ready for bed. Because it's crazy with all the fireworks and stuff. What's going on over here? Go like this. Let's go here. Oh, do I really only have one viewer? Okay, so we're just going to leave. We are just going to leave.